Hello and welcome. We're going to talk about phase diagrams in this video. Phase diagrams show the different states of matter at different pressures and temperatures. So it's a two-dimensional graph that shows regions. Here there's purple, which is solid, magenta, which is the liquid, and then this brown is the gas. And then we have the critical phase, which isn't really depicted on this graph, and I'll talk about that later on. All right, so we also have these lines, and remember that we have these different phase changes as you cross from one region into another, okay? And the points where these lines intersect or end are very important. They're called the triple point and the critical point, okay? So pressure is on the left axis. That can be in millimeters of mercury, torr, or atmospheres, and temperature usually is in degrees Celsius. So first off, this is called the melting curve or the freezing curve. And basically, when you go from left to right, you're going from solid to liquid. That's melting. When you're going from right to left, that's called freezing, okay? And this is the vaporization curve or the condensation curve, and it has a curve of that shape. And we actually have, it's a logarithmic function. It's from the Clausius-Clapeyron equation. And so we have actually a very good description of the pressure at different temperatures for a substance, okay? And this curve down here on the bottom left is the sublimation curve or the deposition curve. Students usually are less familiar with sublimation or deposition, but we'll go into that in a little bit, okay? So that's the line or the curve there. Where you have that three-way intersection, that's called the triple point. And that's where solid, liquid, and gas are all at thermal equilibrium with one another, okay? So water can boil and freeze at the same time as it exists as a liquid or a gas or a vapor, for example, at that point. The next thing I want to talk about is the critical phase. First of all, the critical point is that point right there at the end of the condensation curve. And the critical phase is actually a region of high temperature and pressure, and it's where a liquid and a gas stop being distinctly a liquid and it stops being a gas. And a critical phase is one that has properties intermediate between a gas and a liquid, okay? It's very strange. All right. First of all, the phase change is induced by temperature change. So if you increase the temperature, it could cause something to melt. If you decrease the temperature, it could cause something to freeze. So let me illustrate. Again, we have temperature on that horizontal axis, okay? So when you take a solid and you increase the temperature, it's gradually going to increase in temperature and melt. So melting is from left to right. And the opposite would be freezing. So if you lower the temperature of a liquid, it eventually freezes. And that's denoted here by the little arrow, okay? Vaporization, again, is if you heat up a liquid high enough, it's going to evaporate or vaporize, right? Liquid water after it rains will just slowly evaporate. If you put sanitizer on your hands or something like that, the alcohol will slowly evaporate and go away, okay? If you're topping off your tank of gas, gas falls on the ground, it's going to vaporize and go away. This is not boiling, okay? It's just vaporization. Condensation is the reverse process. We all have had that experience of having maybe like an iced soda or iced tea or something on a hot, humid day, and it's just building up little liquid droplets on the outside. That's condensation. Again, if you cool the gas, it's going to change into liquid. Sublimation, like I said, is a little bit more complicated. Mothballs is a typical example of this. They're round pellets, and if you put them on the ground, they just slowly seem to disappear, and yet you can smell the vapor from them, okay? So that gives you an idea that it's changing from a solid to a gas. It's not just disappearing, okay? And that generally happens at low pressures, okay? Deposition is the opposite of this. This is when ice crystals form. I've shown that in my other video. That's when you go from a gas to a solid, and so if a gas is cooled down, it'll eventually form a solid, and that's at low pressures, okay? Low pressure. The normal boiling point is always related to the normal pressure, and we're talking about the planet Earth here on our videos, so that's 1 atmosphere pressure, okay? So the boiling point of a substance is the intersection of the 1 atmosphere line with the vaporization curve, okay? And for water, for example, it's going to be 100 degrees Celsius. Benzene might be 80 degrees. Gasoline will have a different value. So it depends on the substance, okay? In the case of water, we know the normal boiling point is 100 degrees C for 1 atmosphere. We'll talk in other videos about what that boiling point will be at 2 atmospheres. At 2 atmospheres, the boiling point is going to be higher. What if it's 0.5 atmospheres? 0.5 atmospheres, the boiling point is going to be lower, okay? So the boiling point's not always just 100 degrees C for water. It depends on the pressure. What about the normal freezing point for a substance? That can be found from the normal pressure, which is 1 atmosphere, and where that intersects the freezing curve or the melting curve, okay? For liquid water or solid ice, that's going to freeze and melt respectively at 0 degrees Celsius, okay? If you increase the pressure or decrease the temperature, that value will slightly vary. At low pressures, right, you have the triple point, and even below that you have sublimation possible, okay? So sublimation and deposition are possible if the pressure is below the triple point pressure, okay? Melting can be induced by increasing the pressure, and this is done by ice, okay? For example, in glaciers or Europa, a moon in the solar system, right? Because of the vast amount of ice that's above a certain amount, at the bottom there might be liquid water present under those high pressures. If you take a piece of ice at this top little dot, and then there's a blue arrow pointing to the bottom, if you take a piece of ice at that temperature and pressure and you increase the pressure, it's going to eventually change to decrease the pressure. It's eventually going to change to a liquid, right? So high pressure is up on the top. If you decrease the pressure, this substance will actually change to a liquid. If the freezing curve is opposite slope, going up to the upper left, like with ice, if you increase the pressure of solid, for example, it would actually freeze, not melt, like in this case, okay? All right, so methane, here's an example of a triple point, a phase diagram, and you can see the triple point is labeled number 1, the gas is labeled number 2, and the critical point is labeled number 3, and we have a few questions about this just to begin thinking about this. So what's the normal boiling point of methane? Well, here you want to look on the graph and find the 1 atmosphere, okay? And you want to go all the way to the red curve and see where that intersects. And if you bring your finger down, then you can kind of read it off the graph. It looks like maybe 160 degrees Celsius or so, okay? It's a negative temperature. All right, below what pressure will methane sublime? Okay, so you look for the triple point, which is labeled number 1, and you find out what the pressure of that is. It looks like 10 to the minus 1 atmospheres. Any pressure below that will allow sublimation, right, to go directly from solid to a gas or gas to a solid. So the answer is below 10 to the minus 1 atmospheres. What is the critical temperature and pressure of methane? So again, you want to read the pressure and temperature of point number 3, which is called the critical point. The pressure looks to be between 10 and 100 atmospheres, so maybe that's 500 atmospheres or something. It's a log plot, so it's hard to read. And then the temperature looks to be about minus 80 degrees Celsius, okay? What's the freezing point of methane at 1 atmosphere? So again, you find out where the pressure is at 1 atmosphere, and you see where that intersects the cooling curve, which is blue here, and that looks to be about minus 180 or negative 160 degrees Celsius. So it needs to be that cold before methane will freeze, and that's why on Titan, for example, you can have liquid methane occurring at the same time as solid methane. It's possible for it to rain methane on that planet and also be in a solidified form. There might be solid chunks of icebergs that are made out of methane, so we'll call them methane bergs, floating in a lake of methane on the moon Titan. All right, what is the state of methane at STP? So standard temperature is 1 atmosphere, okay? And then the temperature, you can look, oh, it's way over there in the gas, okay? So the state of methane at standard temperature and pressure. If we're talking about gases, normally we talk about point number 2 is 0 degrees Celsius and 1 atmosphere, okay? And that's for gas. Okay, so point number 2 is STP, all right, standard temperature and pressure. All right, what is the state of methane on Saturn's moon, Titan, okay, having a surface pressure of 1.5 atmospheres and negative 196 degrees Celsius, okay? So you find 1.5 atmospheres, a little above the 1 atmosphere mark. and you move to the right and you find negative 196 there, and you can kind of see it's right around the liquid solid part. Okay, so as I mentioned, you could have liquid methane and solid methane on the Moon Titan, so it's around solid or liquid there. Okay, so that's basically it for phase diagrams. You're just reading off the graph. What happens if you increase the temperature at this point? What happens if you decrease the temperature at this point? What happens if you increase the pressure or decrease the pressure? And then reading off, okay, what is the state at these conditions or those conditions? Okay, so just be aware of the terms, the phase changes, the critical point, the triple point, and regions of solid liquid gas are always kind of like in a clockwise manner, starting with the left. Okay. Thanks for watching. Please like, please subscribe if this was at least a little bit helpful. Have a great day, everybody.